Assalamualaikum class. So through this video I'm going to discuss all the answers to the questions, and we are going to go through all the options, and we'll be covering the concepts which have been covered by the questions in this worksheet. So question number 1 is, a meter rule is used to measure dash. So we'll be starting from the option E. So remember, for force, you measure force either by using a spring balance or by using a Newton meter. Okay? And then for option D, time, remember we measure time either by looking at the clock or by using a stopwatch. The stopwatch can be mechanical stopwatch or an electronic stopwatch. We can measure time by pendulum. We can measure by pendulum clock, and we can measure time by the hourglass as well, right? So we don't measure time using a meter rule. Then B is mass. So remember, for mass we are going to use either an electronic balance or we use the beam balance. So now we are left with option A. So option A is length, right? And remember, for length we have few equipments that we use to measure length. Number 1 is we use measuring tape, we use meter rule, we use vernier caliper, right? So these are the things through which we can measure length, right? For example, if I have to measure length of a very small object, so I'm going to use a vernier caliper. If I have to measure a huge length or a huge distance, I'm going to use a meter rule, right? So according to different scenarios, our choice of instrument changes. So part number 2 is units given by the System International or a Standard International for measuring physical quantities are called. So for in order to see its abbreviation, remember we take first letter from the word, right? So in system we are going to take S, and in international we are going to take I. So this is going to be SI units, so which is option number D. The smallest possible measurement on vernier caliper is, okay, so in your book, if you have looked at your book, it says that for vernier scale you use 0.0 n, right? So 0.01 centimeter is the smallest measurement, but that's in centimeter, whereas the options over here are given in millimeter. Now centimeter is a bigger unit compared to a millimeter, right? So we have to convert 0.01 centimeter into millimeter. So when we convert it, we see that it becomes 0.1 millimeter. So 0.01 centimeter is 0.1 millimeter. So option B is the correct answer. So we will rule out A, because A is 0.01 millimeter. That's not centimeter, right? And then ampere is the standard international unit of. So D is force. Remember, for force the standard international unit is Newton. You should memorize all the standard international units for all the physical quantities. For electric current, I'm going to come on that again. For part B, time. So for time, the standard international unit is second. Remember, we can measure time in hours, we can measure time in minutes, we can measure time in milliseconds, but the standard international unit is second. So when you have to report the time in some paper, or when scientists talk from different places around the world, they use standard international units, because remember, according to different places the units change, right? So for example, over here we use the word pau in Urdu, but this pau, no other than Pakistani knows exactly what does this pau mean. So we have then concluded, all of the scientists, they basically concluded that they are going to use a standard international unit in order to avoid confusion, right? And then for A, for temperature, the standard international unit is Kelvin. Remember, we can measure temperature in degrees Celsius, in Fahrenheit, and in Kelvin. So these are all the possible units, but the standard international one is only Kelvin, right? So option C is electrical current, and the standard international unit for this is ampere. Now an instrument which gives a level of high accuracy than mechanical stopwatch. So remember, with time, due to progress and due to incorporation of more technology, we have moved to electrical appliances and to the system which basically uses electricity, right? Because electronic devices are much more accurate, right, and more reliable. So remember that whenever they use the word electronic with something, that should give you a hint that this is probably the one which is going to give us the best possible measurement. So A is the right answer, right? And then for pendulum clock and for hourglass of a stop clock, they are going to help us know the time, but that's not going to be as accurate as an electronic stopwatch, right? Now pendulum clock is basically when a pendulum oscillates, right? So pendulum moves, it takes a swing and it moves from one point to another. So basically that is used to measure time. Now let's come to the vernier caliper. So vernier caliper helps in measuring. So for this, I request you all to open up your book and look at the image of a vernier caliper. When you look at the image of vernier caliper, you will see that at the front you can see that there are some jaws, which there are two set of jaws. One is called the internal jaws and the other one is the external jaw. And then on the opposite side you'll see that there is a rod called a depth rod. So that depth rod is used to measure the depth of narrow tubes, and for external, internal diameter and for thickness, you basically use a vernier caliper. You use the jaws of the vernier caliper. Now this vernier caliper is basically used to measure the thickness and the diameter and depth of something which are basically smaller in size, right? For example, if I ask you to measure the depth of let's say a huge tub, then you're not going to use a vernier caliper. But if I ask you to measure the depth of a bottle cap, then you're going to use a vernier caliper. Now write true or false in front of each statement. Also rewrite the false statement. The SI unit for time is minute. I told you that time can be measured in a lot of by using a lot of units. For example, we can use minute, we can use hour, we can use milliseconds, but the standard international unit is just second. We use force meter to measure mass. I've already discussed this in the MCQ section, so please go back, revise, and then write down the answer. So the answer, of course, is false, because mass can be measured either by using an electronic balance or by using a beam balance. Length is a distance between 2 points, and that's of course right, because it is a distance between any 2 point, right? Now suffixes change SI units by factors of 10 to smaller or bigger units. So basically by factors of 10 means that it either makes it smaller by 10 power minus 2, 10 power minus 3, 10 power minus 1, or it makes it bigger by 10 power 1, 10 power 2, 10 power 3. So 10 power 2 means that this 0 is going to come 2 times. So 10 power 2 is 1 with 2 zeros, right? And 1 with 2 zeros makes 100. This is that 10 power 3 means 1 with 3 zeros. So that makes 1,000, right? But for example, if you again open your book, you'll see that there's a table which shows the prefixes. So prefixes, the literal meaning of the word prefix is the word that comes before another word, right? So for example, if meter is a standard international unit, then you'll see that there is also another unit called millimeter. So milli is coming before the standard international unit, which is meter, right? So milli in this case is a prefix. So remember that prefixes are used to either change the SI unit by factors of 10 to smaller or bigger units. So that's called a prefix, not a suffix, because suffix is something that comes after it. So it isn't meter milli, it's millimeter, right? So we are going to go with the prefix. So this answer is wrong because it talks about suffix. The volumes of liquids can be measured using volumetric flask. Okay, now volumetric flasks are basically those kind of flasks which have the volume written over it, but like 15 millimeter or 15 milliliter or 10 milliliter, but it isn't as accurate as a graduated cylinder or as a measuring cylinder, right? Because now basically volumetric flask is in which you basically make the chemical mixtures. That's usually used for holding the chemicals, for holding the liquids, and for preparing the chemical mixture. If you have to measure the volume of a liquid, you are going to use a measuring cylinder because that is going to give you an accurate answer, right? So volumetric flasks are mostly used for, that will just tell you that 15 milliliter of reaction mixture can be made in this, but that is mostly used for holding things. Remember when I used to take you all to the lab, then I used to use a beaker for holding for a beaker which used to contain some liquids or which used to contain the chemicals. But when I used to measure a volume, I always used to use a measuring cylinder because that is more accurate and that has proper readings on it. Now the volume of seashell can be measured by dash method. So now seashell, if you look at the shape of a seashell, it's not a regular shape, it's an irregular shape. Now for regular shape, remember we do have formulas. For example, let's talk about a cube. So cube is a three-dimensional form, a 3D form of a square, right? So the formula is length into breadth into height, and because it's a 3D form of a square and we know that square has equal lengths, so it's length into length into length, or all the sides are basically equal. Just like that, for cuboid, it's a 3D form of a rectangle, and for that the formula is length into breadth into height, right? So just like that, we have formulas for other regular objects, right? Now, but if something is irregular in shape, then for that you use a method called displacement method, right? So displacement method works this way, that you have some liquid in a measuring cylinder, right? And see over here, I'm going to use a measuring cylinder, not a volumetric flask, because volumetric flask is not going to give me accurate reading for that. So in that, for example, the water right now in a measuring cylinder is filled up to 20 centimeter cube. I put a seashell in that now, and I'll see that there's a rise in the water level, and that reaches to 30 centimeter cube. So now this change of height from 20 to 30 is 10 centimeter cube. So this change in volume which is 10 centimeter cube is basically the volume of a seashell. So now this is called a displacement method. Why? Because it has displaced the water. It has displaced the water level, right? So the SI unit for volume is, so the perfect way to remember this is by its formula. So for regular objects, the formula is length into breadth into height. Now length, breadth and height are all actually the distances between different vertices. So they're all the distances. And remember, the SI unit for any distance or for any length is meter. So when you multiply meter 3 times, meter into meter into meter, that makes meter cube. So that is how the SI unit of volume is meter cube, right? So you should be able to derive the formulas and the units. The mechanical stopwatch can measure time intervals to dash. So mechanical stopwatch is less accurate compared to an electronic stopwatch. So it can measure time up to 0.1 second. Space occupied by a substance is called its dash. So if you look at a definition of volume, so volume is basically the space which something occupies. For example, water. Remember when we used to pour water in a measuring cylinder, we used to measure the volume. We used to measure the space that water occupied. Okay, so it's just a space. So the dash is equal to the total distance traveled divided by total time taken to travel. So in maths you must have studied the formula for speed. So this formula for speed is equal to distance over time. Now when we talk about the total distance over total time, that gives us average speed. Now why am I using the word average? That's because that, you know, for example, you go from your home to the school, right? You travel from your home to the school and you see that throughout this journey your speed keeps on changing, right? So the time at which you cover the distance, that changes for each road depending upon the traffic, right? So the speed changes throughout the journey. So what we do is that we take the average speed. So average speed is that you take the total distance into account and you divide it by the total time. Now question number 4 is, take the reading for the following pair of vernier calipers. Now over here you can see that this bigger scale is basically the main scale and this smaller scale is called a vernier scale. So this smaller unit is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now have you seen that over here the lines are basically calibrated over here. So it's written what does this line stand for. This line stands for 1, this line stands for 2, and this line stands for 3. But for vernier caliper, the values with the lines are not written, right? With the calibration is not written. The value isn't written. So remember that this is always going to be 0. This is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, how do we take the reading from a vernier caliper? Remember, you have to basically do it in a stepwise manner. So step number 1 is that you always take the reading from the main scale. From the word main, you can infer that it is something that is of topmost priority, or that is something that has to be done first. So you take the reading from the main scale. And how do you take that? You look at the 0 reading on the vernier scale. So the first reading is the 0 reading. Now look at the main scale reading. What is coming on the main scale before the 0? So it is 3.6, right? 3, 3.1, 3.2, 3.3, 3.4, 3.5, and 3.6. So before this 0 mark, this is coming, which is 3.6, right? So you write 3.6 centimeter over here, reading on main scale. Now look at the reading on vernier scale. So reading on vernier scale is basically given as 0.0 n. So n is the value which coincides with the reading on the main scale. So which mark is coinciding? Look for that mark. So this is 1, 2, 3, 4. 0, 1, 2, 3, 4. So look at the 4th mark on the vernier scale. It is exactly coinciding with the line on the main scale, right? So this is basically 4. So you're going to take this measurement, and this is going to be n. So you, in place of n, you're going to write 4. So 0.0 n. Now you have seen that the value is 4, so you're going to write 0.04. Is that clear? So this mark on the vernier scale is n, and whatever that n is, for example over here this n is 4, so you're going to put that 4 in place of n. So this is going to be 0.0 n. So now this is going to become 0.04. So you write this value over here, 0.04 centimeter. Now see, because it's written over here that centimeter, so I have written 0.04 centimeter. If for example they would have written millimeter, then I would have written it as 0.4 millimeter. Okay. Now the width of the object is going to be 3.6 centimeter plus 0.04 centimeter, which is going to give me 3.64 centimeter. Remember, when you add things up, the units should be same. So if the main scale reading is in centimeter, then the reading on vernier scale should also be in centimeter, so that the total reading is also in centimeters. So it needs to synchronize. Now reading on main scale. So this is again another practice question. I think now you can do it yourself. Take the reading from the main scale, take the reading from the vernier scale. I'm going to help you with the reading on the vernier scale so that you understand it better. So you're going to look at the line which exactly coincides. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or why don't you do it yourself? Just practice it and then get the answer checked, right? So you're going to take a reading from the main scale. You're going to take the reading from the vernier scale. That reading is going to be n. I'm going to give you a hint. The coinciding line is over here. Something that is after 2, 3, 4, 5, after 5. Okay. So you take that reading from there, you add them, and that is how you get the width. Now look at this. Calculate the area of the following irregular surface when area of one square is 1 centimeter into 1 centimeter. So remember, the formula for area is length into breadth. So in case of square, the length and the breadth, they're equal, right? So 1 into 1 gives you 1 centimeter square. So each area of each unit is basically going to be 1 centimeter square. Why am I saying that? Because see, this length and this width one is the length is 1 and the width is 1, so 1 into 1 is going to give you 1 centimeter square. So the area of unit square is going to be 1 centimeter square. Now for irregular object, what you do is that you put that irregular object you draw that irregular object on a grid, and then you start measuring the squares which are complete or at least half filled. So they have said the total number of square completely filled or at least half filled. So you will count it, right, and you write down the total number of squares over here. Then area of each unit square is 1 centimeter square. Now how do you calculate the area of an irregular object? You're going to multiply the total number of squares by the area of the unit square. Okay, so this is how you will get the answer. Please ignore the squares which are not half filled. If something is less than half filled, ignore it. Okay, now question number 6a. The following diagram shows three readings on a meter rule. Circle the correct one. Remember, when you take a reading, your position of eye level matters a lot. And you will come across this point many times when you'll be appearing for your O-levels. So they focus a lot on this, that you have to keep your eye level right perpendicular to the reading, right? So look at these three eye levels. Which one is exactly perpendicular to the reading? Is it perpendicular? Is it making an angle of 90? Is this making an angle of 90? No. Well, is this making an angle of 90? Yes, of course, right? So the middle one is making an angle of 90. So that means this middle eye is basically making an angle of 90. So this is perpendicular to the reading. Now, this is very important that you position your eye perpendicular to the reading, straight, because in order to avoid the parallax error. Okay, so what is the name given to such eye positioning, right? Now, how can we take correct reading? So you can take correct reading by putting your eye exactly straight over there, perpendicular to the reading, so that you can avoid the parallax error. Which instrument would you use to accurately measure length of a housing plot? So that's a huge distance to measure, right? So for this, you may use a meter rule, right, or a measuring tape. Circumference of a newborn's head. Now, so for circumference, you'll have to fold something, right? So it's going to be circular in shape. So of course you can't fold the meter rule, but what you can do is you can fold a measuring tape. So for circumference of a newborn's head, what you're going to use a measuring tape. Then the diameter of a ping pong ball, so that's small in size, and remember, for diameters we may use the vernier caliper. The internal diameter of a teacup, for that you can again use a vernier caliper using inside jaws. Volume of milk in a packet. So remember, for perfect accurate volumes you may use a burette or a measuring cylinder. Okay, so that's done. Time taken by an athlete to cover 500 meter. Okay, now for 500 meter, for races, you basically use, because athletes, they run and they compete against each other. So for that, you preferably should use an electronic stopwatch. Why? Because that gives you an accurate measurement of time to 0.01 second. For example, if one if one person runs, if one person takes, let's say, 3.42 seconds to cover something, 3.42 seconds to do something, and the other person takes 3.45 seconds to complete something. So do you see that they only have a difference at 0.01 at the second decimal place? So if we'll have an electronic clock or electronic stopwatch, we'll be able to differentiate between the two, right? We'll be able to recognize who won the race, who won the competition, right? So for more accuracy, you should use electronic stopwatch. Now define speed and give its SI unit. You already know this, right? And I've already discussed that as well. Okay, so the formula of speed is distance over time. So I told you that you have to drive the units. So in order to drive the units, speed is equal to distance over time, right? So you basically take the help from the formula. So the distance is basically the length. So the standard international unit for length is meter, and the standard international unit for time is second. So you write meter in place of distance and you write second in place of time. So that is meter over second. A car took 2 hours to travel from one terminal to another terminal at an average speed of 80 km per hour. What is the total distance traveled by the car? So you have the speed and you have the time. You can of course calculate the distance, and that's easy. The formula is speed is equal to distance over time. Plug in the values that you already have. So you have the value for speed, you have the time. So speed 80, right, is equal to distance is unknown over time, which is 2. So 80 is equal to